Okay, here we go. So a lot of these terms will be familiar to you. In fact, the students in the other class periods said, yeah, we've seen that before, we've seen that before, but there's other things in the lesson that they hadn't seen before. So this lesson is all about measures of center. Middle. Center means kind of in the middle. Okay, so some of these measures you have seen before. Now, in order to calculate all these statistics and come up with all these measures of center, we need a data set. Okay, and what a data set is a collection of data values. And more often than not, a data set is numerical. It's a set of numbers. Not always, okay? It could be letters or other things. But this is math class, so our data sets will always be numerical. And we can do lots of calculations with the numbers in a data set. The one thing that we could calculate is the mean. And there's another name for mean. What's the other name for a mean? Yeah, right, it's the average. Okay? So if I say calculate the mean, you're calculating the average of the set. So how do you find an average? What do?
You add up all the
numbers. Yes, you add up all the numbers and then what?
Divide by the number.
Divide by the number. Okay, so the definition of a mean is the sum of the values. Sum means add, right? And then you divide by the number of values. Easy, super easy. So if there's 10 numbers, you're going to divide by 10 after you add all the numbers up. All right, who remembers what the median is? Rory.
It's the number like in the middle.
The very middle number. Is that always easy to find? Not necessarily.
If there's two numbers and we add
Yeah, so if we have an even number of data sets, it's a tiny bit more challenging than if we have an odd number of data sets. The middle. That word should be the middle. Okay. Sorry, can't put a word that you're trying to define as the definition. That makes no sense. Okay, so the middle value in a data set, when the values are in, this is critical, numerical order. So if you're given a data set, don't just look for the middle number. They have to be in order from least to greatest before you find that. Okay, the mode, the values that occur the most often. And you know what? That's how we remember what mode means. How does mode start? M-O, most often. Okay, so that's how I recall the difference between some of these. Okay, lower extreme or the minimum means the lowest value in the data set. And then, of course, the upper extreme or the maximum is the greatest value in the data set. Okay? And then the range is the spread between the biggest and the smallest. So it's a numerical value representing the spread of the data set or data set. And this is an easy calculation. This is calculated by subtracting the minimum or the lower extreme from the maximum or the upper extreme. So on your 3x5 card, you might just write max or range equals max minus min. Okay. All right. Have you seen these quartiles before? Lower quartile, third quartile? Maybe. Okay. Some of you are shaking your head. But these were the terms that the other students in the other classes like, no, I don't think so. And if I did, I don't remember. Okay. So the lower quartile is actually a median, which is a middle value, right? We just learned that up above. So it's the median or middle value of the lower half of the data set. So we're going to divide the data set in half somehow, and we'll talk about how we do that later. And then find the median of the lower half, and that's called the first quartile or the lower quartile. Okay? Then the upper quartile or the third quartile is the median or middle value of the upper half of the data set. Okay? And we refer to the first quartile as Q1 with a little subscript and the third quartile as Q3. Yes?
So is the median of the whole data set considered the second quartile?
Yeah, kind of. Yeah, they never call it that. They just call it the median. But yeah, technically, it would be the second quartile. Okay, the number that's punched out here is, the letter that's punched out here is the letter I. Yes?
It's like called the first quartile and the third quartile. Is that like supposed to mean something like there's no second quartile?
Well, like she just said, the actual median could be referred to as the second quartile. Okay? No, not really, because it's kind of just divided up into thirds. Okay, but you will never hear me use the term second quartile. Okay, it's always first quartile, third quartile, and the median. The median is the middle one. Okay, the letter that got punched out here was the letter I. This is interquartile range, or the IQR. And that's a numerical value representing range is a spread. Okay, so it's a numerical value representing the spread of the data from the first quartile to the third. So this is actually calculated by subtracting the first quartile. From the third quartile. Or the lower from the upper. Regardless, it's found by taking Q3 and subtracting Q1 from it. Okay? Okay, last definition, an outlier. What's an outlier? Rory?
A number that doesn't really fit in with all the other ones. It's kind of like, let's say, like all the other ones are between 1 and 10, and the outlier would be like 35.
Yes, exactly. Okay, it's a number when you're looking at the data, like all of them are kind of bunched together, and then one's like way over there. Like he said, they're all somewhere between 1 and 10, and then this other one's 35. That's an outlier, okay? So it's a data point that lies an unreasonable distance away from the other data points. So if all the numbers were kind of between 1 and 10, and then there was a one that was 11, that's probably not an outlier. Because it's not an unreasonable distance from all the others, okay? But 35 would be. Well, how do we decide what's unreasonable? Well, there's a little formula. Outliers are calculated by multiplying 1.5 times the IQR. So you take that interquartile range and you multiply it by 1.5. And then either add it to Q3 or subtract it from Q1. And then any number that's on the other side of that calculation is an outlier. Okay, and you'll see what I mean by that when we go through some of these examples. Okay, Maggie.
It's really obvious that the outlier is like 35. Do you need to do the...
No, if it's super obvious, you do not need to do the calculation. Okay, but sometimes you may think, oh, there's none, when there really are. So I would always recommend doing the calculation if it's not super obvious. Okay? Rory, did you have a question? Stretching. Okay, here we go. Here's our data set. Don't work ahead in the notes, by the way, because we changed some of them. So, Okay, here we go. Example 1. Here's a set of data. I don't know, maybe it represents the ages of people in a very large family with some triplets and some twins. I don't know. Okay. I don't know. I don't know what the data set represents. But regardless, the first thing that we need to always do is order the data from least to greatest. Okay? So I see 2 4s, so I start with the 2 4s. And then I'm going to cross them off. And then I see 1, 2, 3 10s. There's the triplets. Okay, and then there's 14, 15, and 16. And then 22 and 25. So there's my numbers. Now, I'm notorious for leaving things out, so I'm going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 4, 6, 8, 10. Okay, I got them all. You should always check. Always make sure that you haven't left one off when you've reordered it. And by counting them, I now know my bottom number in my mean calculation. Okay, because when you calculate the mean or the average, you divide by the number of numbers. Okay, so let's add those up. Did you use your calculator?
No.
Okay, good. I was going to say don't use your calculator.
I lied, I didn't.
Super easy to not do your calculator. How would you add these in your head without using your calculator? Well, here's 30. Here's 8 and 22. There's another 30. So I'm now at 60.
There's 40.
Here's another 30, 14 and 16. So now I'm at 90. Okay, and this is 40. 90 plus 40 is 130. Sometimes.
How come we can't use your calculator?
Because I wanted you to use your head. That's why. Okay. So the answer is 13 for the mean. Now you'll notice that the mean's not in the list of data sets. That's okay. Your mean doesn't have to be in your list of data sets. Okay, median. That's the number smack dab in the middle, but I have a problem. There's 10 numbers. There's no middle number. Like if I broke it out and I said, okay, that's the middle number. Well, there's 4 there. There's 5 there. That's not the middle. And if I said, okay, maybe it's 14. Well, there's 5 there, 4 there. Definitely not the middle. So you take both the middle numbers. You take both the 10 and the 14. Now there's 4 over here and 4 over there. And that works. So the median is going to be 10 plus 14, and I divide by 2. I find the average of those 2 middle numbers. Okay? And 10 plus 14 is 24, divided by 2 is 12. And then my mode. Mode stands for most often 10. Because there's 3 10s. Okay. Minimum, maximum range. No one's going to get that wrong. Minimum is 4. Maximum is 25. And the range is 21. Okay, Maggie, question.
For the mode, if there's multiple, if there's like another that also has 3, what was which one?
You list them both. Yes, because if you go back and look at the definition, it says the values that occur the most often. So if there was 3 4s and 3 10s, you'd list 4 and 10 as the mode. Okay. All right. Now let's look at this first quartile, third quartile, and interquartile range. Can this data set be divided exactly in half?
Yes.
Yes. Okay. With 1, 2, 3, 4, 5 numbers in the first half and 5 numbers in the second half. Okay, so it can be divided in half. So the first quartile, Q1, is the middle number in that lower half. So it is 10. Yeah, it's right smack dab in the middle. And in the third quartile, It's 16, yes, the middle number is 16. And then my interquartile range, you subtract the 2 and you get 6. All right, now we're going to make sure that there are no outliers in this data set. So the way we do that is we take 1.5 and we multiply it by the IQR, which is 1.5 times 6, which is 9. And then I'm going to add that to my Q3 to see if there's any outliers that are too big. So Q3 plus 9 is 16 plus 9, which is 25. So close, but no outliers. 25 is not an outlier. It has to be bigger than that value, okay? Even though there's a 25 in my data set, it is not considered an outlier, okay? So, none. All right, now we got to look at the other one. We got to look at the lower side. So I do Q1 minus 9. Okay, at the other end, I subtract it. Okay, and Q1 minus 9 is 10 minus 9, which is 1. There are no data values that are less than 1. So again, none. So there are no outliers for this data set. Close, but not quite. All right, Samantha.
So if you like calculate the outliers and there's a number above or for Q3 or below Q1, then those are the outliers?
Yeah, so for example, if there was a 26 here, that would be considered an outlier because it's bigger than 25, okay? Okay. All right, let's look at the next data set. This is the problem that we changed just slightly. We changed this problem just slightly. So these are the scores of 17 students that they received on a math quiz. One student took it late and they got a 75. So that number gets added to the list. All right, so the first thing, we're not going to cue you in on this, by the way. We're just cueing you into this on the notes. But the test is not going to say, first thing, reorder the data. You've got to remember to do that. Okay, that's critical, that you remember to put the data in the correct order. All right, so let's go ahead and do this. What's the smallest number? 42, right? So there's a 42. Cross it off. Then what's next? 52, yes. Then what's next? 66, and it looks like there's 2 of them. 66 and 66. And then
72.
I see a 68. Okay. So 68. And then 72. And how many 72s are there? 2. Okay. 72. 72. And then, yeah, there's that 73. All right. Then 74. And then there's 2 75s. There's the one in the middle and the one that we added. So 75 and 75. Then, oh, did we get 68? Yeah, I forgot to cross it off. All right, then what? 80. Then 82. Then 84. 80, 82, 84. Then 91. 92 and 98. Okay, now I'm going to make sure I have 17 numbers listed there. Yep, I do. Okay. You may use your calculator to calculate the mean. We know we're going to divide by 17. Okay. So add up all the numbers and we'll see if we all agree on that top number. Tashiki, got it? Got your calculator? Ah, that's why I asked you to grab a calculator at the class. Everyone's calculating. Calculating.
1092.
Okay, I heard 1,092. That's one number. Anyone got a different one?
I got 1260.
1,262. That's another number. Rory?
1262.
1262. Anybody else got a number? 1262. 1262. Sounds like the answer is 1262. So you might, when there's a long list like that, you might want to add it twice. Okay? All right. And then divide by 17. Yeah, if I do 1,262 divided by 17, sorry, I did that wrong. 1,262 divided by 17, you get that number, okay? 74.23529412. We want you to give us a number with one number past the decimal point. So 2 tenths, okay? And you're going to round it, okay? So if this number is lower than 5, that number doesn't change. If it's 5 or bigger, this will change to a 3. Okay, so that's our rules. Different teachers, different schools do different things with 5. Okay, we round up if it's 5. Got it? Okay. So the answer then would be 74.2. All right. Is there an exact middle? Yeah, because there's an odd number of data points. So if there's an odd number of data points, there's an exact middle. So I want to find 16 on each side, or 8 on both sides. 1, 2, 3, 4, 5, 6, 7, 8. There's my lower. There's my upper. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And so 74 is my exact middle. What's my mode? Z. Yeah, careful. Don't just start rattling. Yeah. Yeah, look at them all. Look at all the data, okay? 2 66s, 2 72s, 2 75s. They're all modes. Okay. Minimum, 42. Maximum, 98. Range, 56. Okay. First quartile. Does the first quartile have a middle? No, because this is my lower half of the data. And that's my upper half of the data. When there's an odd number of data points, your median is not included in either the upper or the lower half. Okay? So I have 8 here. So again, I have to take the middle 2. Okay? The middle 2 there to find quartile 1. So 66 plus 68 divided by 2 is most definitely going to be 67. And in the third quartile, these are my numbers. Okay? For those of you who weren't sure there, I'm just going to put the calculation there because it's not always going to be that nice. Okay, but if the two numbers are, if there's one number in the middle of it, that's how it's going to work out. And this is 83. You could calculate that by adding them together and dividing by 2. And my IQR, 83 minus 67, you're right, 16. Thanks, Ethan. All right. Do you think there's an outlier? Let's check it and see. So first thing I do is 1.5 times the IQR, which is 1.5 times 16, which is 24. Okay. So we add Q3 plus 24. Okay, well that's 83 plus 24, which is 107. So none there.
Wait.
Okay.
Q3 plus 24.
Yeah. That's how I calculate whether or not there's an upper outlier. I take Q3 and add 1.5 times the IQR. Okay? And so none there. There's no numbers bigger than 187. Let's look at the other one. I take Q1 and I subtract 24. So that's 67 minus 24, which is 43. Is there an outlier? Yes. Okay. There's an outlier. 42 is an outlier. Okay, so it wasn't an obvious one, but it is one based on the definition of what an outlier is. Okay. Okay, so do you think the mean value in this scenario is the best measure of center? When we calculated that average, is it the best? The answer is always going to be no if there's an outlier. The best measure would be to recalculate this without that outlier in it. Okay, so we would, to recalculate it, what would we do with this number? Subtract 42. What would we do with this number? Make it 16, because now I'm not including one of the numbers. Okay, so a better representation of center would be to eliminate the outlier. So is it? No, because there is an outlier. In this class, there's always lots of outliers in the math test because there's 106% in this class. When I'm calculating the average between all three of my Algebra 1 classes, if I want to get a really good picture of what the outlier is, I have to drop a lot of the tests in this class because there are students that get every problem right plus the extra credit. Okay, those are good outliers. I like those outliers. All right, so a better calculation, okay, a better measure of center would be if I took that 1262 and I subtract the outlier. And then, of course, since I'm subtracting one data point, I would do the 17 minus 16. Okay? And so what's a better measure for that mean?
Wait, do we need to do the better measure?
That's what I'm putting in the notes. If it asks you to do a better measure, yes, you do.
Why did you do that divided by 17 minus 1?
Because now I have one less data point,
Oh.
right? Okay? This means one less data point. It's just easier than re-adding all the numbers, right? Yeah. So 1262 minus 42 is 1220 divided by 16. And a better would be 76.2. No, 76.3. Right? Because you got 76.25 and we agreed to round up. Okay, so that's a better one.
Oh, we're gonna have to do that on the final.
Maybe. Yeah, not without a calculator. Everyone has a calculator on the final. Okay. Okay. We are not going to answer these. So is this outlier a mild outlier or an extreme one? It's mild. It's just like it almost made it in there. Okay. But it still affected our average. Okay. And what would be a possible reason for that outlier? Maybe they didn't study. Maybe they were sick or didn't feel good the night before. What else could be an explanation? Huh? Yeah, just bombed the test. But why?
Maybe
They obviously bombed it.
Maybe they didn't see the backside.
Yes. Do you know that used to happen?
That happened to me.
It doesn't happen in my class anymore because if a student turns in their test pretty early, I look it over. And sometimes they're turning in early because they missed a page. And then I hand them their test back and they redo it. I always check if I'm like, wait a minute, they've only been working half an hour. That doesn't make sense. Okay. So maybe a struggling student, or maybe they missed a page. Okay. All right, turn the page. So this was a bunch of data that represents the time it takes for people to fall asleep at night. It was a research project done by this Dr. Pitts. So go with you and your table partner, work through all the questions. There is obviously an outlier. In this case, it's obvious at one end. What's the obvious? 95. Still include it in all your data up here. Okay. There might be another one. There might be another outlier. The other day after being here and not being sick,
This is not really responsible.
I went home. I took a 3-hour nap. I woke up and I went to bed for the night. Yeah. Sometimes that's all your body's telling you. How many data sets? How many data points? 16. Make sure you have all 16 in your list. You average them.
I thought it was 18 plus 19 divided by something.
Because you're adding two numbers. That's called the averaging. Yeah.
Yeah. 27. What? I did not do that.
And
Ah, okay. I think it's 14 and 22. So
Okay, so if you haven't finished yet, don't worry. We'll kind of finish it up at the beginning of next class. I need to show you something about the homework. Okay, so don't worry about the notes. Okay, we'll finish it up at the beginning of class. I think you guys get it. I think you get how to do all of it. But here's the thing on the homework. The front page, I give you all the data numbers. Okay, they're all there. Remember, you got to order them, etc. But on the back page, they're presented differently. Okay, so here's a graph, and this is the number of births per woman in different countries. So each point represents a data value. So there's 1 in the data set. There's 1, 2, 3, 4, 5, 6, 7, 8 2s in the data set. How many 3s? And how many 4s? Yes. Okay. Now this one is about goals in a hockey game. What do you think our first data point is?
7-1.
No, this is just the game.
1.
No.
There's 7 goals.
7 goals. So 7. Then what?
Oh,
There's 1
2
goal in the second.
Oh,
1, 2 ones.
No.
1.
1. Yes. Then what?
Oh, 3.
3. Then what? 3. Okay, you got it.
Oh, okay.
And then here, each point represents a data. Okay? So your data starts with 2, and then 4, and then 6, and keep going. Okay? But I would write them in order kind of as you go. Okay? Leaving some space. Okay? All right. We will look at the answers to that last one, that last little thing that you did when we were in class together on Friday.
How am I really fast?
So for this, yeah. So if you like count out like the, you know,
Wait, what did you do here?
that's the
18 plus 19.
because it's in between.
Yeah, but 18 plus 19 is 37, and 37 divided by 2 is not going to be 27.
I was gonna see my calculator.
That's because you don't know how to use a calculator. If you enter 18 plus 19 divided by 2, your calculator is designed to do order of operations. So this is what you need to do. You need to do 18 plus 19 and then push equal and then divide by 2. Okay? You're welcome. Exactly.
Okay, yeah, that's the best way. It's just that I don't
You're
have
welcome. See you Friday.
Thank you.
You're welcome to Shiki. See you Friday.
Thank you. Have a nice day.
You too, yeah. Have you got your phone?
Yes.
Good.
So so like the reason I was that I'm gonna be missing those 3 days
Yeah.
is because I have to visit my grandma. 'Cause he's
Yeah.
sick.
Yeah.
And I don't know if I mentioned that.
Yeah.
I did.
Yeah.
Okay. Because then like I just don't want like my teachers to have to go on like vacations. Because it's a lot of days to miss, especially in finals.
You need to go see your grandpa.
Yeah. Also the like the note card thing. So I would just
When are you taking it? The day of class? So I'd like you to like give it to me next Tuesday.
I'm sure it would be Thursday or Friday.
Thursday. Yeah. So next week we meet Tuesday and Thursday. So during our class period. Yeah. And you'll get more than the class period. Because the final exam period is 2 hours long. So they will let you stay for another half hour after the bell rings.
So do I have to come here beforehand?
No, go right to the testing center, okay? And I'll have your test and your note card and everything in a folder for you. Okay? Yeah.